Welcome back. This is part 2 of the 6.4 notes. We're going to just keep going with example 3. And in this case, we're going to be asked to find 3 different derivatives of inverses given a table of values. So you got to be careful as you go through and look at these. Again, I find it important to make sure you realize the relationship between the function and its inverse. So let's take a look here. For part A, we want to find the derivative of the inverse at 5. That means that we're looking for the output of the function to be 5. And the inverse has an input of 5. So this becomes the important value that we need because the derivative of the inverse at 5 is going to equal 1 over the derivative of the function at whatever that output value is. So you got to look at the table and look at the information you're given. You're given f of x and you're given the derivative of f. That means when you go to the table over here, you're looking for the output of 5. So the output's going to be the value down here, the f of x, which is here. So the output of 5 gives you an input of 9. So 9, 9, 9 is what's going to go there. And then once you've got that figured out, it's a matter of substitution to find the derivative. So we're going to end up with 1 divided by, well, the derivative of f at 9 is 1/4. So 1 divided by 1/4, which is 4. So right there, the derivative of the inverse of f at 5 is 4. And you really can go through and just kind of follow that process all the way through for these. So here we have f, which is going to have an output of -1 because the inverse has an input of -1. So we are looking for 1 over the derivative of f at kind of that unknown value. So again, we want to go back to our table and we want to figure out which f has an output of -1. Well, that's here. So 5. In order for us to find the derivative of the inverse at -1, it's going to be 1 over the derivative of f at 5. So that's 1 divided by 2/3, which is 3/2. And as you get the hang of this, you can start to do these problems without having to maybe write f and f inverse. But you got to, make sure you understand what you're looking for. So as we go to do C and we want to do the derivative of the inverse at 11, then it's going to be 1 over the derivative of f at. Well, again, go to your table, find where that output of 11 is. We get 7. So 1 divided by the derivative of f at 7 is 8, and 1/8 becomes the answer. So, what I find helpful, like I said before, is you've got to understand the relationship between that value. When you're looking for the derivative of the inverse of a function, whatever the output of the inverse is, that's the input of the function that you want the derivative of. All right, let's go ahead and take a look at example 4. So now we're given that f of x is x to the 5th plus x cubed plus 2x. G of x is the inverse of f of x. We know that f of 1 is 4, and we want to find g prime of 4. So again, let's just start with that relationship. Here's f. All right, we want an output. F needs an output of 4. So G is going to have an input of 4. And we are going to try to find G prime of 4, which is going to come from 1 over f prime of kind of that unknown value. So if you look here, we were given that f of 1 is 4. So when f has an output of 4, the input's 1. Well, that helps us quite a bit when it comes to finding that value, because There it is. So at that point, we need to know what is the derivative of f of 1. So we can take our function, we can find the derivative of f, which is going to be 5x to the 4th plus 3x squared plus 2. And then we can evaluate that derivative at 1. So 5 times 1 to the 4th plus 3 times 1 squared plus 2, which is 5 plus 3 plus 2, or 10. F prime of 1 is 10. We can come right back over here and substitute and get our answer of 1/10. All right, we have one more that we're going to take a look at. So in this case, example 5 says, given that h of x is 3x cubed minus 12x plus 5, q of x is the inverse of h of x. We want to find the derivative of q at 2 if x is less than 0. So again, let's kind of start here. We've got h of x in this case, and then the inverse is q of x. So we want to find the derivative of q at 2. So q has an input of 2, which means h has an output of 2. And what we're going to need to do is we're going to need to figure out what that value is, right? What is the output of q and the input of h? Because for q prime of 2, it's going to be 1 over h prime of whatever that value is. So that's going to be our key, is to figure that out. So if we set up our equation, 2 equals 3x cubed minus 12x plus 5. We could set it equal to 0. 0 equals 3x cubed minus 12x plus 3. We could factor out the 3, but we really don't have a way to easily solve that. So if we get our calculator out, we should be able to just use the solve function algebraically to find those values and then figure out which one to use. Sorry, this is taking a little bit of time to pull up. All right. There it is. All right, guys. So what we're going to want to do is we're going to go ahead and we're going to go ahead menu. We can go algebra. We can solve. And we can just type in that equation. 0 equals, what is it? 3 times x to the 3rd power. Make sure you get out of the exponent. And then we have minus 12 times x plus 3. So we set it equal to 0, but then we got to tell it to solve for x. So we're going to go comma x, enter. All right, and you'll see that we get 3 values, which should make sense because it's a cubic function. So we've got negative 2.11491, 0.254102, or 1.86081. So if we come back over here, x is going to equal either, negative 2.115. What was the decimal of that? I guess it was 11491. And then if you look there, x has to be less than 0. And going back here, the other zeros were all positive. So we can reject whatever else came after that, and that has to be the value that we're looking for. So we need to know what h prime of negative 2.11491 is. So that's going to require us to figure out what is the derivative of h real quick. So h prime of x is 9x squared, that's minus 12. And then we're going to evaluate that at negative 2.11491. And we can plug that in our calculator. So 9 times negative 2.11491 squared, and then minus 12. And that gives us negative 52. Let's see. Oh, I think I did something incorrect there. Let me try that one more time. So 9 times, and then in parentheses, negative 2.11491. We want to square that, and then we want to subtract 12. All right, so we get 28.2556. So this is basically 1 over 28.2556. And if we plug that into the calculator, 1 divided by 28.2556, it's about 0.035. And since that's our final answer, we want to round or truncate at 3 decimal places. So we get an answer of 0.035, and that is our Q prime of 2. All right, guys, hope you found the videos helpful. I will see you next time.